presentation, I've updated it, so you can share it.
Okay, that's fine. Okay, this is my screen. This is what I'm going to be sharing.
Perfect, looks good.
It's exactly 10 o'clock Pacific time, so let's give it a minute for users to join and we'll get started. Welcome to the Virtual Manufacturing Users Forum. This is the first session, and we hope to bring in some really good, insightful topics around machine learning and its relevance to the current world business application in the context of using it for Tableau user community. We look forward for a very active participation and discussion. Salil, if you can go to the next slide. Thank you. Okay, it's a minute over 10 o'clock, and we see a lot of folks who have joined in. So let me quickly introduce myself and my other speaker. My name is Manju Devdas. Spent decades of my time and career solving analytics, predictive analytics, and now machine learning for in the supply chain manufacturing domain. And I'm also the CEO of Pluto 7. We are a Tableau partner. I've solved business problems for hundreds of Tableau customers, and I've gained enough insights on what they look for, the pain, the business problems, the technology challenges that they face. And through this conversation, we hope to not only share our experiences, but more importantly, hear from all of you. This is a user community. It's not a one-way conversation. It is a user community. We want to just to get the interest and excitement going for this round. We will be sharing some of our learning experiences and our knowledge in machine learning, analytics, Tableau, and how we are collectively changing the world of the user community. And hopefully, this will be a starting point for such conversations, and many of you will bring in topics for discussion in the following session. I'm the moderator for this session, and I have my colleague Salil Amonkar as well, who will introduce himself in a few seconds. So we'll keep re-emphasizing this at different points in the session, that we need to hear more and more from you folks, whether you want to discuss some of them in the Q&A session. At the bottom within the UI of this conference, you will find a Q&A and a chat session. We strongly recommend you use the Q&A icon and post your questions so that we can have discussions around it, around your question. And also, if you have interest of presenting, towards the end of this presentation, there's a slide where we'll share our contacts as moderators so that we can plan for the follow-up sessions with your participation. What you see here is background about myself. So I've spent decades not only with working on these analytics, but also various cloud partners, Google, AWS, Microsoft, and so on. So Google also, in some of the content that we share, you will also see us refer to Google's machine learning. They've been using machine learning starting with Google search engine for decades now, and that is expanding. So, for Tableau community, how can we leverage all of this to make differences to our own business, clients' businesses, and customers' businesses is what this discussion will be all about. Salil, do you want to go ahead and introduce yourself and take it forward with the content?
Thank you, Manju. You can see my profile up there. I'm just going to add a very few things to what Manju said. And most important is that, like Manju, I've been spending a lot of time working with manufacturing industries and also high tech industries in the valley over here. And what we hope together today is to share with you our collective experience on not only the analytical progression, but also what is now capable with what we have actually seen with some of the cloud technologies and advanced visualization, especially the one that is provided by Tableau. So we're going to bring it all together based on our experience. But what I would like to have is a more interactive session. We're going to quickly walk everybody through our view and help us by making sure that if you have a point of view, like Manju said, again, reminder to everybody that you put it in your Q&A instead of chat, and we will then respond to it. Let's make this a very interactive session and bring your questions and go from there. So with that, what we are going to do is quickly introduce you to machine learning and some of the supply chain use case studies. So machine learning has been there in areas that perhaps some of us know about it, but maybe some of us don't know about it, especially in form of product recommendations. This has been embraced by a lot of the e-commerce and retailers long before, like Amazon.com, Netflix. If some of us who are using Netflix, we actually see this in terms of recommendations being made to us in terms of what we watch and then the recommendations that come as a result of it. And I'm not sure if all of you have figured this out, but I've been a Netflix user, and what I've seen is 2 years ago when I was watching Netflix, the recommendations were not really to the mark. But lately, I'm seeing that they are pretty much on the mark in the sense that if I watch something, the recommendations come pretty close to what I really would want to watch. And a lot of that has to do with machine learning and the advances in machine learning that they have actually implemented. Similar things you will see in Amazon.com as well. Now, machine learning, and why are we talking about machine learning in context of virtual manufacturing? Well, most of you coming from this background should be familiar with this. Today, as well as in the past, the classic thing that pretty much everybody in manufacturing has to deal with is optimizing the demand that is placed on the manufacturing organization and optimizing the way they fulfill the demand. And here you see the manufacturing supply chain and the fact that everybody in manufacturing wants to be at that spot where we call it the sweet spot, where you want to optimize the demand and the supply equilibrium. A lot of it, as has been done in the past, has been managed through, has been managed through a lot of systems that have progressed over time. What we want to show is how you can enhance this even further. And in situations today where there's explosive demand with a lot of offerings that are very complex, where it is almost impossible now for human beings to review the traditional way of managing supply chain, where machine learning with its dynamic business rules in combination of advanced visualization that's provided by Tableau comes together. And that's going to be the crux of our discussion today. Just a quick overview of the evolution of we are calling it the machine learning path, but all of you who have dealt with analytics before would recognize that this is nothing but a progression of analytics and business intelligence over the last few decades. We started with initial analytics based on simple RDBMS that you provided as reports, transition that to advanced analytics using multiple OLAPs with some hard schemas. But now with the advent of cloud-based analytics, we now, and combination of ability to look at huge and manage huge data, and with machine learning, now it's really coming together where you can really provide actionable information on business real-time basis that's available everywhere. And this is really going to be a game changer for not only the front-end retailers, but also to the manufacturing, especially virtual manufacturing supply chain. So I talked about evolution of BI and now leveraging advanced analytics. So machine learning versus BI. So what's the big difference and what are the key advantages? The big difference is in traditional BI, which has existed long before today, the key thing is always about human beings defining the business rules that you actually code into the analytics solutions. Machine learning, on the other hand, is really about taking the data, understanding the patterns, training the data, looking at the rules that apply, but then also looking at what rules machine learning will show up so that you can look at patterns that you would never be able to do with human knowledge, not because that we are not able to do it. It's just that sometimes there's incredible amount of information and incredible amount of change going on that you need to be looking at the business rule change in such a fast manner that's not possible to be done using traditional BI. So that's where machine learning driven business rules come in. So some of the cases that we want to talk about where we, based on our experiences and based on what discussions we are having with customers on solutions that we are actually providing between Manju and me and the team that works with us, is, for example, the forecast accuracy and how you want to determine the demand forecasting with the highest forecast accuracy is a very excellent case where you can really use machine learning to hone that in. Another one is how you can improve not only your on-time shipment, but also make sure that while you do that, you are keeping the inventory optimized by not getting into an excess and shortage situation. And related to both of these are some of the rest of the use cases, which is, if you want to be specific, which a lot of manufacturing people face, is how do I drive down my expediting, which is basically customers saying, I need this faster than you promised because you could not make my initial schedule, or as a manufacturing organization, you are now trying to catch up to the promised date. And then, of course, the promotions, where you want to sort of, the reason for sales and forecasting promotions is not only about improving revenue. Sometimes you want to get rid of excess inventory and that you want to tie it to promotion. Doing this with the traditional method versus machine learning, you get a lot more input and manageable information when you use machine learning in context of some of these use cases. We are going to focus, for the purposes of the discussion today, on the forecast, how machine learning has been used in some of the activities that Manju and I have been directly involved in improving forecasting for some of our customers.
So Salil, if I may add one point here, right, on the previous slide. One of the key things to keep in mind is, as you look at this list, these are all the use cases, right, where we see machine learning being applicable and in discussion with various clients. When you look at this list, one question, one thought might occur is like, yeah, these are traditional problems. We have always solved this, right? That's exactly the point, right? The problems that you have to solve in supply chain, they will always remain problems. With the evolution slide that Salil showed earlier, how you solve the problem changes, which is 30 years back you did with simple reporting from dot matrix printers printing out, right? Then eventually it got into a little bit sophistication of analytics where you started having some flexibility in terms of just instead of printing like 40, 50 pages and then sorting your information through, then you started having some flexibility. Then came analytics where you could drag and drop and start building hierarchies and got some really good sophistication with Tableau, which has a fascinating and an amazing design and which has a strong user base. We got all those flexibilities. Now we are going through this journey of going to the next stage where, okay, now we have great visualization. Now the data underneath needs to be enriched. Machine learning is a solution for that, right? Keep that in mind. Keep going, Salil.
Thank you, Manju, for adding that very important context. Okay, so since we are talking about forecasting, and I know that a lot of you know this, but just in case, just to remind everybody, why is forecasting so important? Because the way we think is, if you think about the entire value chain as a series of highway, expressways, roads, forecasting is really analogous to setting the stage for the rules that will govern how traffic will move through these highways. So with that as an analogy, if you consider the fact that those rules are that important, then therefore your forecasting, which drives the initiation of this traffic, it becomes very important. And the way to measure the importance of the forecasting is that the forecast accuracy is the primary measure, because if your forecast is accurate, then you will ensure that your supply chain flow from the start to the finish is much more accurate or as per your plan. And the accuracy, just as a reminder for everybody, is what is accuracy? It's nothing but what you forecasted compared to what are the actual observations. So if you forecast demand, then whatever you forecasted, you subtract that from the actual orders coming in, and then that gives you a measure of your accuracy.
So Salil, if I may add one simple example here, right? About 10 years back, I was working with a big manufacturing firm, and in the course of implementing some analytic setup, right? And I was the hands-on guy doing that. And during that implementation, the company's stock price fell by 10%, and there was a sense of, it's almost like 10 to 20%. There was a sense of panic, a very stable stock. Why did it drop, right? So, well, in discussion with the C-level executives, there was this natural, conversation around blaming organizations, blaming softwares, and so on. It went on for a couple of weeks, and then at the end of the day, what we did was, between myself and with a small team, we really went into the depth of the data and looking at what really is the data telling. It turns out that there were some flaws in how they were forecasting, and the flaws were because of literally 2 to 3 people in the company, right? And how they were feeding the inputs and so on. So then at that point, it became evident that the dependencies were the people and the process behind it, which is what ended up creating bad data, which created forecast inaccuracy, which led to stock price drop, right? So it was a pretty amazing experience of going through the whole thread. And as many Tableau experts that are there on this call, many of you would have faced it, right? It's easy to call a dashboard to be bad, or a dashboard doesn't make sense, or my dashboard doesn't meet so and so. When it comes to and if we all know, the power of data underneath it, and a bad data is a byproduct of bad forecasting process or a bad people actions, then we know that the eventual dashboard will be good. So in the forecasting scenario, we'll show you some examples as we go through. Go ahead, Salil.
Thank you, Manju. And that's a great point. And the reason I say that's a great point, because I'm sure, like you, a lot of us have been involved in all the time spending enormous amount of time working on figuring out why the problem happened, because once these kind of problems happen, they do have an impact, significant impact from a business perspective in the manufacturing operations. And then sometimes, to your point, Manju, it takes a whole bunch of time figuring out where the issue is, because of the fact that you have to sift, even if you are looking through BI systems or dashboards, a lot of time you have to, there's this whole dialogue that happens around where is the data coming from. People focus more on validity of the data, comparing data from different sources. So all those issues then make it even more complex, which I'm sure a lot of people in the audience have faced. So good point. And I'll come to that point again later quickly in some of the solutions, as you'll see, where we have implemented, how we have leveraged machine learning and data sciences to help avoid as much as possible this type of situations. So these are the challenges that Manju talked about that I just alluded to. So I'm just going to quickly put it up there. A lot of them have to do with the data preparation, exploration, and visualization, in the sense that as most of you probably are in an enterprise settings, there are a lot of data, even within an enterprise, data sources, data repositories, a lot of different kinds of reports that are then developed. People tend to come up with, okay, which report is good? What is the right report, right? A lot of point solutions. Sometimes there are silos. All of these are challenges. How do you take models and you integrate them in business processes? This is where you define the business rules. But again, these rules defined by human beings, sometimes the business is changing so fast that it's unable to keep up with these rules. All of these are important elements that at the end of the day drive as actionable information. Although we are talking about forecasting, a lot of these issues will be there for any other solution that is using business intelligence analytics that drives a business process. And then sometimes if you are in an organization, an enterprise that deals with volumes and volumes of information, especially if you are in, like, for example, enterprises where you are manufacturing consumer goods, right? Electronics, a lot of orders, transactions, then you have a lot of transactions in your system where in order for you to be able to develop the business real-time information, then the performance and scalability also comes into play. Okay, it's no Q&A, so I'll just continue. What is machine learning? We talk about machine learning in context of dynamically adjusting business rules. So in a very simple form, it can be encapsulated into three things. First, there is the element of data. Like most of you who have dealt with analytics know this, right? And especially if you have worked with statistical models before, that in order for you to predict something, you need information. So, and you need the information in a way that you can use to make some sense. Now with data, the way you have data, you collect it, you store it, you prepare it. There has to be a certain amount of discipline that goes around that piece. So creation of the data, setting it up so that it can be useful to run a machine learning algorithm. So that's one part of it. Data preparation, sometimes data blending, you'll hear these words. It's all about managing the data in a way that you can use it and feed it into a machine learning algorithm. That's one piece of it. The second most important piece of it is now making sure that you have the right machine learning algorithms. There are many different models. Machine learning is a science that has different models, just like statistics has different ways and models. Picking the right algorithm and going through that and defining this will require a lot of not just only technical experience, but a lot of insight into the domain that you work with. For example, for all of us in the manufacturing supply chain area, understanding the important elements, for example, around the demand management, various sources of demand, the variations, the type of attributes that will drive the demand, like the attributes of the products that are being sold, the services that are being sold. What is the right algorithm to set up, and how do you set up those algorithms? So one of the key things will be, if you want to go into details, is setting up the algorithms, and then what we call in machine learning is training the algorithms. So setting those things up and making sure that these are set up in a way that will then take a look at data, look at the data patterns, and then generate the insight. The insights are really nothing but what is it that the algorithm has detected with all the data that is being fed into it. What insights are being generated that will be of use? And I used the word training before, and the reason for the training is you will want to make sure that you check your algorithms with some known samples to ensure that your algorithms are geared towards giving you the insights that you desire for your domain. So,
if I may add,
yeah.
here, right? So, for the audience, right? So, if you think about the comment that Salil made earlier, right, which is around Netflix, what he said was, hey, compared to 2 years back, when I look at my Netflix recommendation, it's a lot more accurate. Why is that? It is because the machine learning model has been running for a while, and it has got trained more and more, which means Salil has been watching a lot of movies, and he's been rating some movies, and there's a pattern on the kind of movies that he watches, and so the key thing is there is a constant stream of information coming in, and the pattern is becoming more and more evident. Now, when the recommendations come out, which is in the form of insights, the movie that they recommend is a what do you call accurate. Now, in the supply chain and manufacturing context, right? Whether you're looking at top 10 products that you need to worry about excess, which I'm talking about the insights now, or top 10 products where you need to worry about shortage, or you're presenting, you have excess inventory and you want to get rid of them by giving top 10 recommendations of for the sales so that they can go sell these products, or the customer itself sees these 10 products are on sale. All of this is coming through that algorithm. Now, the key difference, what is the key difference here? The key difference is, if you go with the analytics and reporting mechanism, you prepare the data, you run or schedule the job for that report, you pull the data, and you'll publish the data, right? That's the traditional way. Here, you have to think about your data is constantly coming in. It's constantly being refreshed every second, and the algorithm is running 24/7 every second. The insights are getting updated. You log into Amazon now, you'll get, if you look for certain searches, you might get something. You log in like 3 minutes later, you might get something else. Why is that? Because the algorithm is constantly running, right? So this is a fundamental notion that it sounds very simple, but it takes a while for us to get it right. Because many of us have, at least I can talk for myself, we have grown with the career of, there's a set of requirements, there's a set of parameters, there's a set of hierarchies, there's a set of filters, and this report needs to be published in so and so. Now, for Tableau community, the insights part of it is where it plays a big role. Tableau plays a big role, right? You're constantly feeding information, and the insights need to keep getting refreshed like every minute, every second. So, go ahead, Salil.
Thank you, Manju. And I will add on to what Manju said when I talk about an actual use case that we will go into more detail further. So, machine learning for forecasting, like I said before, right? You prepare the data, and for forecasting, what are we talking about typically here? We're talking about either past orders that are there, your order history or your shipment history. But more importantly, it's about making sure that you continuously keep adding the additional information on top of it, right? You could pull in your customers' data to add to your own data. You could pull in other aspects. That would be your data related to forecasting, and now you build in your forecasting models. To Manju's point, earlier what we did is we built in statistical model, whether it was basically your linear forecasting and exponential or the best fit method that you'd use. Now you want to put in certain elements that would then I'm going to go into the details of machine learning, but there are a few models that from a machine learning perspective you can do, like cluster analysis, collaborative clustering, where it will look at data coming in, it will look and generate insights that you would not even have got around forecasting. For example, Manju gave that example where you might have a product. Like if you are in a distribution business where you are distributing textiles, as an example, your product is coming from factories that are producing fabric, but now the myriad of models that can be put on that fabric in terms of the patterns and all of that, that is potentially a lot of attributes, a lot of information changing. No matter how many business rules you would put in, machine learning will give you and say, hey, for your demand that you are assuming based on history, that you using normal methods, you would have got a certain element of what the forecast should be. With machine learning, it will say, by the way, here's something that a lot of customers are actually ordering. You may want to do, we suggest that you do an uplift for this particular product or downlift for that particular product. So this is an example in forecasting, and even if I give an example of textile, but if a lot of you who are working in the valley, you're talking about even high tech things like, for example, in the Samsung mobile world or in Apple's world, with so many variations on the iPhones and other elements, and with the combination of both hardware and software and the offerings that a lot of high-tech companies now have to think through, your machine learning, now you can anticipate the complexity of forecasting, where you don't have to worry about going through a whole bunch of information just to figure out where my potential problem is. The machine learning will tell you, hey, here are the products you probably want to look at that I want to highlight to you where it needs your attention, because your forecast that based on history is a lot less or a lot more. And so therefore you have to take some corrective action. So that's an example why we feel, but not only why we feel, because we've actually put together a solution that has helped one of our customers, where we have put in some of these machine learning concepts, and that's why we want to highlight it today. So I talked about training a little bit, and I also talked about, when I described the very simplistic way what machine learning is. The key thing here is, as in anything, when you talk about machine learning, a lot of it has to do with training. And in putting together a machine learning solution, this is the most important piece. The first part that you need to get right is getting some data that you can use as a reference data. You build some models using machine learning. There are some 20, 30 techniques, and then which we are not going to go into detail today, but if there's interest in that, you guys can contact us. We'll have that information towards the end of this session. The key thing is, you take the data, which is your sample data, and typically you don't start with the full data. You will want to look at certain, for example, if you are looking at some high technology products, you will take some specific product families to start with the data related to that. Ideally, you want to take not only your internal data, but you also take some data from your customers or things that you can gather. put it together, put some models, and now you do what is called as training the model. Think about it as like in a very simple example. If I want to see, if taking the Apple iPhone as an example, right? When Apple came up with all the colors, and if we want to say what color do I think is going to be the most prevalent. So if I want to look at that and taking an example of the iPhone 5C, which are many colors, or any other phone, you want to then take that particular iPhone family, you want to pull up data from your own past ordering history, but more importantly, you would capture some data on customer preferences coming, what the customer actually buying from the end, from the retailers. You put that together, and now you, based on that 5C, you know how 5C models actually work in the past. So you use that, and then you put together the machine learning model, and you say, what is the output looking like, right? Because now you have a known output. You see what the model is telling you, and you see that in this case, okay, Apple 5C, this is what we saw in the demand that was generated. And now, what is the model? When I put the same data through this machine learning model, what recommendations did it come up with? Now, with that, you have a known data set, you have a known result, you check the results, and now you verify that my machine learning model is actually working as intended. Once you verify that, then what you do is, and you can do all of this locally. You don't have, when I say locally, it means that you can do this on your own laptop. If you have a decent sized laptop that will handle, which most of today's laptop do, you can do all of this on your laptop. And then once you train the models, you feel confident, you have trained it. Now you can put it through a check where you can look at all the data, do one more test. This is where you can probably leverage like the cloud. If you don't want to use an on-premise data store, you use the cloud. Google Cloud provides a good option. There are other cloud as well that can provide a good option. You put all of this, and now you run the whole machine learning through that, and now you start looking at the data for your current products and all products. So this is how a typical machine learning solution is put together. Okay, Manju, you want to add anything to this?
No,
Some of the experience.
with that context, let's progress to show some live example. Keep going.
Okay, so let me just talk about a few other use cases that apply to machine learning quickly, which is I sort of alluded to this, not necessarily core manufacturing, but manufacturing in terms of if you are in an organization and your organization has to sell, you can do upselling, cross-selling, but then you can do that in context of driving your inventory down. You can drive your expedites down, because if you're selling to something where you are able to meet the customer's demand, most likely they will not be able to do the expedites, or there should not be any need to do expedites. And then, of course, if you want to expand this to the most important piece, which is increasing the margins, you want to figure out what is the right price to charge so that you get the most margin on the sale. So all these are classic cases where machine learning can help. And then making sure that when you are looking at, for example, the last use case where we talk about location with user preference, a lot of that can help, for example, with distribution. Okay, when you're like actually saying, when would my customer want to do the pickups of my product? And this is where that comes into play. So this is one example of where both Manju and I were involved in helping a customer put together and use a machine learning solution to help with some of the cross-selling, upselling capability. Just want to sort of quickly give you a view of what the business use case was and what the key considerations were in building the machine learning based solution model. Manju, you want to add anything to this?
No, the only thing I would like to highlight here is it's interesting, like in terms of patterns, of who experiments with machine learning, right? There are certain domains that we see are ahead in the game with machine learning, especially the banking and insurance industry and so on. There are certain industries like retail are really catching up, and I'll talk about it when we show an actual example.
Yeah.
But when it comes to manufacturing and supply chain, generally speaking, we feel, and my opinion might change in 6 months, right? We feel like, where this community is slightly lagging behind, although there's a fantastic example of jet.com and amazon.com who have set this trend. At the same time, it's amazing to see how small vendors and small players are thinking innovative, and we'll talk more. Keep going, Salil.
And then this one is what I think is very important, because this is something what we have solved for one of our customers, is really on how you can bring together what I shared before, machine learning solution in forecasting, and then carrying it downstream, which a lot of you guys are pretty much familiar with, and then matching it with your inventory and supply to really manage the excesses and shortages effectively. The problem today is, even with all the solutions, I see enterprise after enterprise having a special project just to drive down excess and manage their shortage. And this keeps coming up again and again and again. So the reason for highlighting this use case is, between both Manju, me, and our teams, I keep seeing this everywhere in different customers of different sizes. And this is a prime example for leveraging machine learning. Reason why this excess situation happens usually, or a shortage situation happens, is right now the demand variations come in so fast and so quickly that even with the best of the traditional forecasting techniques that are used, no matter how sophisticated they are, being built on rules that were built through the traditional methods, the changes in demand really creates a situation that then causes either an excess to be generated or a lot of time shortages to be generated. And so now enterprises then have to keep handling those on a manual basis with some special projects, more cost. And at the end of the day, this is a cost to the enterprise. Also, the current solutions, if you really want to handle this, you have, as most of you must have encountered, it really requires special reports to be created. There will be a lot of queries being generated, a lot of reports being asked. So we want to showcase how we have helped one customer manage this. And I think that with that, I want to, and just to set the context for this, it will also showcase not only how this was solved, but this will showcase how you can use Tableau visualization power effectively. And I believe, Manju, if I'm not mistaken, this solution we presented as a case study to Tableau, who then presented it at TC16. So with that, I would ask you to, and both Manju and I were involved in this solution very deeply. So Manju, if I can ask you to go into the depths of that solution and also showcase to everybody how Tableau as a front-end visualization tool now can sit on top of machine learning-based data management to effectively give actionable information to distribution or a manufacturing supply chain user.
Great. Thanks, Salil. And let me share my screen. So, Salil, if you can stop sharing, I'm going to share my screen. All right. Thank you. So at this point, many of you are wondering, can you see my screen?
Manju, we can.
Okay. So at this point, many of you are wondering, hey, I'm a Tableau user, and there's a lot we spoke about from in the context of machine learning, right? I build dashboards, I build visualization. This seems way too sophisticated for what I do. I'll have you think through this a little bit more. So we worked with many large companies, right? And we continue to work with them. Some of the largest companies that you can think of who are on Dow Jones, we worked with them, solved their problems for decades, and they can spend millions of dollars and so on. Some of these projects runs for a long time. In the Valley, we happened to meet some two brilliant CEOs, right? And one of them I'll discuss here. So these CEOs are brilliant. They are visionaries, and they run small organizations. And they reached out to us a while back and said, "Hey, my number one worry is Amazon.com, right? What I do is I manufacture textile material. I have to do it in different locations in my supply chain, and it has to reach on time, and it has to be cost effective, price effective, and also the expectation of customers to deliver on time is really critical. So this is one of the case studies that we'll share, and this organization primarily thought that that analytics is too expensive, and product recommendations and those kinds of things are a dream state, and it's not, they can't afford it, right? So now we took that as a challenge. Yeah, walking into a big organization and doing this is pretty straightforward, easy, right? As in, because they have money to spend, they'll experiment. If something goes wrong, they'll do it again, and so on. But doing for an SMB is incredibly complex because the constraints are really tight, and on top of it, you're now trying to build something which competes with Amazon.com, right? Now, similarly, we met the second CEO we met. They ship perishable goods, food, right? Think about the constraints they have. The food has to be on the shelf with X amount of hours of life, right? After that, milk which expires in 3 days or 2 days, less than 2 days, nobody's going to pick up that milk, right? So the whole distribution of that has to be very tightly managed. And again, and milk is one, then there's produce, then there is other kind of food, and now again, Amazon is their threat. So for us, this became an interesting challenge to look at, hey, how do we leverage Tableau and machine learning to get them to a point where they look at beyond Excel spreadsheets and beyond having all this labor trying to figure this out, right? So, and we'll show you the working model behind it. So this company, for example, they build, manufacture textile goods, and they distribute to Macy's, Nordstrom, Walmart, Amazon.com, Hotlook, and so on, right? So we got them onto Tableau, started using the analytics and so on, and then eventually now they're starting to think about how do we go increase our presence online. Now, the message we have to take here is many of you come from many different size organizations, right? A small player is thinking of machine learning. A small player is leveraging Tableau, right? And they are thinking on the lines of how Uber operates, Airbnb operates. These guys are innovative, right? Now, which means there's a bigger disruption expected in the next few years. We spend a lot of time with Google, and this message is becoming more and more clear. And Tableau is the visualization layer. I'll show you the sample which Salil mentioned was showcased in a Tableau conference as well, which has which brings all these things together: forecasting, machine learning. It runs entirely on cloud. Okay, so let me just go to my screen. This is what was shared in the Tableau conference. This is Tableau dashboard embedded. But before that, let me show you. So if you think about the machine learning, there are 3 stages, right? We are data preparation. Then there is data, running the machine learning model, then visualizing the output, right? So now look at this content over here as output out of the machine learning, right? First, you can view your output. What you see here is planning in a box. This is a solution we had to build for one of our customers, and this runs on the cloud. So once you generate the machine learning output, you can view your output, and you can ask questions, right? What's the average selling price? Like, for example, let's see if I can ask a question here. What is the average selling price? Like in this case, for example, right? Like I'm not even the machine has generated the various insights, and I've now been able to see this, and also to product recommendations based on this and the customer's buying pattern. I can now recommend products to my customers. Now, this is what a product recommendation will look like. Sorry about that. So let me just log in again. So a product recommendation will look like this. So you saw the forecasting output, and when you're selling, let's say you're one of the distributors of high-tech equipment, right? So you could go ahead and based on who is ordering the product, what product they're ordering, you can sort out the recommendations. So essentially what you did in the previous screen was you saw your forecasting output and which has propensity to buy, and you identify the top 10 products that you want to recommend, and you have your recommendations of top products you want to recommend to the customer or similar products. What is this analogous to? It is analogous to what you see in Amazon.com. Like, for example, if I go and say Samsung UHD, right? Ultra high definition, I want to buy a television. And when I select one of them, not only do I get to see this, the machine learning in Amazon.com has already figured out that whenever customers buy television, they also buy wall mount, right? Do you want to buy them together? And also, by the way, if you're considering that TV, take a look at these other TVs, right? And so on. So the whole idea is you're really understanding the customer's buying pattern and showing these kinds of information using machine learning. Now, the relevance for this is more wider and deeper in many companies than what it looks right now. The customers, what we are working with, want to apply and embed this within their sales force so that their salespeople can, when they're talking to customers, can really see what products are there. Now, if you look at this, there is a supply optimization here. If it's front-end upsell, cross-sell, why from manufacturing I care about it? You want to have enough supply for the true demand, all right? And if your forecasting is right, if your forecasting is accurate, you plan the right amount of supply, and whatever supply you have, that's the only thing you want to promote. You don't want to promote something which is not there, right? So, and as a part of this, we had to implement. They wanted to run everything on the cloud, so we had to go ahead and take this and enable integrate with Tableau Online. So now, essentially, what it meant is the customer did not have to build data warehouse, they did not have to build ETLs, they did not have to build any of the challenges that they have to go through, right? They can directly upload the data that they want to. They can upload the data, whether it's through, what you call Google Doc, Excel, or integration. In this case, the customer had NetSuite, so we had to integrate with them. And show once we gave them the recommendations and so on, they could take it forward by enabling through Tableau Online, or they could also connect the same thing through Tableau Desktop. So this is live connect to the cloud. So essentially, at the end of the day, what we have done here is we have taken, at the end of the day, your visualization layer is still going to be the analytics and from Tableau. Underneath this is the machine learning model, which will do all the calculations, combinations, and highlight only the ones what you should care about. And whether you want to do excess or shortage, or whether you want to do insights of what if analysis after the machine has generated, it's up to you. So that is the background. I know we spent about 55 minutes going through the presentation, and we now want to open it up for Q&A, just to remind ourselves that this is a Tableau user session, so we want to make sure that there is enough Q&A and conversations happening. So there is other capabilities that we can go through at a different time, where we can show how we can embed maps and things like that. Geolocation is becoming another very important thing, which is where is my inventory, right? Tracking inventory is a big deal, both in the case of the perishable food case as well as the textile case. They want to know where the inventory is. Is it on the way on a truck, or is it on the sea? How long will it take? Can I adjust my demand and supply and so on? So with that, as a speaker, we'll stop our sharing our information, and we now open it up for Q&A. So by the way, for the folks who want to understand more deeper on everything that we discussed, feel free to email us. You can also search us by name on LinkedIn, and we'll be glad to help out. What we showed here is essentially Tableau Online, Tableau Desktop, and the solutions that we built for our customer. So there's a question on, like, okay, where is the Tableau demo? What we just showed you is the output out of this, right? Output out of the forecasting running under the machine learning. What we did not share is the machine learning model itself. So there are two aspects to it. There is a proprietary nature of the machine learning itself. There are some in terms of sharing the algorithms and so on. This you will see that across the customers. Sharing their own algorithms is going to be a sensitive aspect, because you will see that there is sensitivity in what is enabled in the algorithm itself. Any other questions? So we see one more question come in. So what the user community seems to be looking for is, they are looking for machine learning demo itself, and also the Tableau outcomes, right? So here is the thing.
So
Yeah,
so Manju, right? If you can just stay on this, what I want you to do is, because this is a Tableau community. See, I talked about the power of machine learning combined to produce results that are actionable, right? So we have massed this data, so this data does not really represent the original customer data. So you can go ahead and showcase like some of this, right? Now, what this is showing, if you see, right, you can bring down, let's put the time frame to, like, let's say February. So if you can put the starting date from like end of February to, let's say, next 3 months, right? Or 2 months. So let's say end of February to end of April. Yeah. Okay. And then the same thing on the second one, on the workbench forecast date. Now, what if you see what this is doing, and once the data comes up, so what you see is that the blue represents the original data that would have been produced had there been no machine learning algorithm put, and now the green represents actually the adjustments that have been suggested by the machine learning, right? And here, by using Tableau, you can immediately figure out, and you can say, now we've done it for one product family. You can actually go and even look up, just put one specific UPC code, Manju, right? Some masked UPC code. You can go and look up for a particular product, what it looks like, what was my original forecast, what is it that the machine learning has generated. This is just an insight. This is not the whole thing, because like Manju mentioned, we cannot show everything. But taking this further in Tableau, and you can in fact take this even more to say, I only want to look at where the differences or a percentage of the differences exceed certain amount, right? Which is what we have actually done. The point is, Tableau, with its very cool and advanced visualization factors, combining with the information creation, really presents a very, very business-friendly way to show the results where you can immediately take action. So and that's the point I wanted to enhance, because the question came as to, well, what about the Tableau dashboard? So go ahead, Manju.
So when it comes to machine learning projects, right? So there's a lot that happens behind the scene, but the output is always quite simple. The output is simple in the sense, top 10 recommendation when it comes to movies, top 10 recommendations, or 5 products that you should worry about in terms of shortage, or the forecast what you thought it is, and based on constantly streaming data what the machine thinks it is. The output is going to be simpler. The whole idea is that you have to have a simpler output, right? Not like sophisticated patterns and clusters and things like that, where you need a genius or a PhD to, I don't have no offense to PhDs, but these folks really have depth of understanding of patterns. But we have to keep the planners and the wider community in mind, where the messages are simple. So there are some more questions. Can I Can I elaborate more on the integration of machine learning algorithm with Tableau? Good question. So the way machine learning output you want to imagine is the following, right? And in the next session, depending on if anybody else wants to present, we can also bring in and share that as well. The question is, when it comes to the machine learning output, think of it as a matrix, right? So you run your output, you have a product by your customer matrix, and those matrix have individual cells have values, right? Now that is the output that you get, right? And that output can be forecast quantity. It could be in that individual cells. It could be forecast quantity, or it's amount of bookings, or any of those things. Now that matrix is what at the end of the day becomes input to your Tableau, right? So that output matrix from machine learning that comes out is pretty much going to be a simple 2x2. You can spit it out into an Excel spreadsheet, or you can write directly into a database table. Hope that answers the question. Okay, the next question. Is the machine learning output stored in the cloud, or is the algorithm processed with Tableau? The machine learning itself, first of all, the whole input, processing of the data, and generating the output, everything happens in the cloud, at least in the solution that we shared. But when it comes to actual generation of the visualization itself, Tableau Online and Tableau Desktop connects live to the cloud.
So Manju, I quickly want to add to that because I ran into it with one customer. So in this case, we put it on the cloud, but absolutely there is no, if you are in an on-premise or an hybrid environment, you can actually run the machine learning algorithm on your on-premise architecture as well. The key thing there I just want to highlight is you first want to train it and test it on your own desktop or a small server, and then before you deploy it. But deployment can be on the cloud or on-premise.
That's right.
Manju.
So the solution what we shared was on cloud. Now, with some of our observation and experience, so this is one of the large companies that we are dealing with. It took them 2 years to build a stable machine learning model, right? This is unlike a traditional BI, a typical BI project, right? Most of our visualization and data model creation projects, to produce meaningful output has taken like 3 months, right? All the way from requirements to generate data models and visualization and so on. This is not this falls in a very different category in the sense to understand the data, to build the model, to look at the output and know that the output is not making business sense, then again go and course correct, which is to continue to train. That iteration itself will take, it does take, if not couple of quarters, it could take a year or 2 years. So you have to be patient and realize that this, and also, model once you build it might not work out. You might have to scrap it and rebuild the model again, right? Because the assumptions you started with, patterns you thought will emerge, may not emerge. Also, the other thing is, when you go through this, you will discover new issues with the data and the patterns itself, and then you go back and create, adjust your assumptions and the data feeds. This is what we referred to earlier as training the model. Now, if there is a request to kind of go through the details behind the machine learning itself, we'll have to do it in a different session because that requires demonstrating the whole setup and so on, and we have to build in some hypothetical models and so that we don't share actual customer data. Any other questions?
So Manju, I saw a total of 5 questions. Did you address every one of them?
Yeah.
And I know we are running out of time. We have 4 minutes over.
We answered all of them. So if there's any further questions, Well, let me share the context again. So feel free to send. All right, let me share that. Feel free to send your questions, comments, and thoughts, as well as also if you would like to present the next round, we highly encourage that. We had to do this first round because just so that the tone for the meeting is set and there is the kind of conversation and interest that we want to generate out of this is set. This is the first round. Obviously, we don't expect everything to go right in this kind of a round. We do expect some learnings to come out of it. So this is a session that we are helping and moderating to bring all of you in together, right? So this is your session. For the next round, we are hoping that one or more of you will volunteer and come in and present, and we will be there to orchestrate and run the show. If not anything, just take everything we presented just as a framework on the kind of things that you want to share. It can be about how did you go about solving, or what are your thoughts about using machine learning, or what are the best practices of visualization relevant to manufacturing and supply chain. It doesn't have to be with machine learning or some of the advanced analytics. It can be pure visualization, showcasing your dashboards or KPIs and like our experiences and so on. Everything is welcome.
Yeah, and to add to that, if you've been very innovative in using Tableau, but you had run into some issues in doing a solution that you would then showcase to say, hey, this is what we ran into, this is how we solved it. It can just be a Tableau dashboard-based solution demonstration as well. It doesn't have to be advanced like machine learning.
Okay, there may be. Okay, there was. Okay, so there may be. I'm hearing that there may be interest in knowing about e-commerce and banking environment, how they have been able to adopt it, and some insights from there. So we'll bring that up in our next session to see if we can bring in an example of e-commerce and supply chain. Okay, that's pretty much it. Thank you, folks. Thanks for joining, and please send us your feedback and opinions. What went right, what went wrong, and also what would you like to hear more. Again, keep in mind, this is the first session, and we would like this to make sure that this becomes a interactive user environment. Thank you.